The internet connects us in countless ways. We use it to work, learn, and socialize. But have you ever stopped to think about how it actually works? The answer, in part, lies beneath the surface of the ocean. A vast network of undersea cables carries a huge chunk of our internet data. These cables, spanning thousands of miles, act as the backbone of global communication. And these are not your average cables. They are designed to withstand extreme pressure, freezing temperatures, and the corrosive nature of seawater. They are a marvel of modern technology, enabling the instant communication we often take for granted. Without them, our digital world would be a very different place. These cables are essential for our fast-paced, interconnected world, carrying everything from emails and social media posts to financial transactions and scientific data. Understanding how these cables work is crucial to grasping the complexity of the internet age. Laying an undersea internet cable is a complex and expensive undertaking. It requires specialized ships, sophisticated equipment, and meticulous planning. The process begins with surveying the ocean floor to identify the best route for the cable. This involves mapping the seabed, identifying potential obstacles, and ensuring that the cable avoids environmentally sensitive areas. Once the route is finalized, the cable laying process begins. A specialized ship, equipped with massive spools of cable, slowly lowers the cable onto the seabed. In shallower waters, the cable is buried beneath the seabed, protecting it from fishing gear and anchors. In deeper waters, the cable simply rests on the seabed as the pressure at that depth provides sufficient protection. The laying process is slow and methodical, with constant monitoring to ensure the cable is positioned correctly and remains undamaged. It's a testament to human ingenuity, showcasing our ability to connect the world even across vast oceans. An undersea internet cable, despite its slender appearance, is a marvel of engineering, comprising multiple layers that protect and power the delicate fiber optic strands within. At its core lie hair-thin fibers that transmit data as pulses of light. These fibers are incredibly efficient, capable of carrying massive amounts of information at the speed of light. Surrounding the fibers are layers of protection. Copper or aluminum cabling provides electrical power to repeaters, amplifying the signal to ensure the data reaches its destination. Steel wire armor provides strength and protection from external damage, such as fishing gear or even shark bites. Finally, a polyethylene sheath encases the cable, providing insulation and waterproofing. This complex construction ensures the cable can withstand the harsh conditions of the ocean depths for decades, reliably transmitting data across vast distances. Despite their robust construction, undersea cables are not immune to damage. Fishing gear, anchors, and even earthquakes can sever these vital links. When a cable breaks, a race against time begins to minimize disruption to internet services. Repairing a cable in the deep sea is a complex and challenging task, requiring specialized equipment and expertise. First, the location of the fault must be pinpointed, often using a combination of signal analysis and underwater robots. Once located, a repair ship is dispatched to the site. The ship uses a grappling hook to retrieve the broken ends of the cable from the seabed. These ends are brought on board the ship, where technicians splice them together using a portable splicing machine, ensuring a seamless connection. The repaired section is then lowered back down to the seabed, restoring the flow of data. The entire process can take days or even weeks, depending on the depth of the cable and the severity of the damage. Section 5: Cables versus Satellites. A tale of two technologies. When it comes to global communication, undersea cables and satellites are the two main contenders. Each technology has its own advantages and disadvantages, making them suitable for different applications. Satellites orbiting high above Earth beam signals over vast distances, making them ideal for broadcasting and reaching remote areas. Undersea cables, on the other hand, excel in speed and capacity. They transmit data much faster than satellites, with lower latency, making them ideal for applications where speed is critical, such as online gaming and video conferencing. The choice between cables and satellites depends on several factors, including cost, bandwidth requirements, and geographical location. Section 6. Cost comparisons: digging deep versus reaching for the sky. Laying undersea cables is a significant investment, costing hundreds of millions, even billions of dollars per cable. However, once operational, cables have lower operating costs compared to satellites. Satellites require expensive launches and have a limited lifespan, necessitating periodic replacements. Once submerged, cables require relatively little maintenance, primarily for repairs. While cables have a higher upfront investment, their long lifespan and lower operating costs make them a more cost-effective solution in the long run, especially for high-traffic routes. Section 7. The need for speed. Why cables outpace satellites? In the world of internet connectivity, speed is king. Undersea cables reign supreme in this domain, offering significantly faster data transmission speeds compared to satellites. This speed advantage stems from the medium through which data travels. Cables transmit data as pulses of light through fiber optic strands. Light travels incredibly fast through these strands, resulting in low latency, meaning minimal delay between sending and receiving data. Satellites, due to their distance from Earth, introduce a noticeable delay in data transmission. The signal must travel to space and back, resulting in higher latency, which can be detrimental for applications requiring real-time interactions such as online gaming or video conferencing. Section 8. The reliability factor: weathering the storms. Undersea cables, despite being submerged in a harsh environment, are remarkably reliable. They are designed to withstand extreme pressure, freezing temperatures, and the corrosive effects of seawater. Their location on the seabed shields them from surface weather conditions. Storms, hurricanes, and other weather events have minimal impact on their operation. Satellites, while providing wider coverage, are more susceptible to weather-related disruptions. Atmospheric interference, solar flares, and even heavy rain can degrade signal quality, leading to slow speeds or even outages. This vulnerability to weather makes cables a more reliable option, especially in regions prone to extreme weather events. Section 9. Challenges and threats to undersea cables. Despite their robust design and remote location, undersea cables face a number of threats. Fishing gear and anchors are the most common culprits, accidentally snagging and damaging cables. Natural disasters such as earthquakes and underwater landslides also pose risks, potentially severing cables. In recent years, there have been concerns about the vulnerability of cables to sabotage or terrorism. Protecting these critical infrastructure assets is crucial to ensuring the stability and security of global communication networks. Section 10. The future of undersea cables: expanding the network. As our reliance on the internet continues to grow, so does the demand for faster and more reliable connectivity. Undersea cables are poised to play a crucial role in meeting this demand. New cables are constantly being planned and deployed to expand the network and connect even the most remote corners of the globe. These next-generation cables will offer even faster speeds, higher capacity, and enhanced security features. They will be essential in supporting emerging technologies such as 5G, the Internet of Things, and artificial intelligence, further solidifying the role of undersea cables as the backbone of our digital future.